It's space weather. Looking at the sun at 304 angstroms. We got 17 tabs open, so no screwing around. A lot of filament activity around the edge of the disk. We also do have a well-defined coronal hole rotating into the Earth-facing region, with which there already appears to be some magnetic connection. Here are some magnetic field strength lines. Please note Sunspot 2733, and down and to its left, the incoming coronal hole. Taking a look at the real-time solar wind, we see that it's quite low. There has been a magnetic connection here with that coronal hole. Solar wind density is all the way down to 0.27 protons per cubic centimeter. And the solar wind speed is diminishing as well, down to 474 kilometers per second. You also see that the 10.7 centimeter radio flux is remaining steady at 72. Let's get a little more in-depth data here from spaceweathernews.com. We have seen some X-ray flux, some B-class flares going on. Also, we see the magnetometer is through with its major perturbations, although there is a magnetic bubble coming from the heliospheric current sheet, which we will show you in a moment. KP index is now at 2. Here's your Cygnets forecast through the 30th. Electron flux has gone up to very high levels now. We'll be keeping an eye on that. Charging hazards are minimal. And the F2 ionosphere layer is extremely discharged. We also do have spikes in the electron count off the coast of North America and down by Madagascar. Note how discharged the F2 layer is. That is because of the incredibly low solar wind density. And aurora forecasts are weak. Let's look at the last frame of the Gong 2 here. You can see a recent crossing of the heliospheric current sheet. See the orange line coming out of the Earth. Magnetometer is going to get weak through this region. And then unless this suddenly changes when it hits these lines, there's going to be a big magnetometer spike once again. But let's see how it plays out in the animation. So yeah, that's an unsettled region of magnetism there. Keep in mind this data is 2 hours and 3 minutes old. Here are your magnetosphere movies. First velocity, which is actually pretty normal. Here's your density, which is going to be very, very low. See at the end of the video that extremely low density solar wind coming in right about there. And it looks like it's already subsided. And here's your pressure. And there's that density dropping off, creating a pressure deficiency. Next, we'll take a look at geospace ground perturbations. Quite a bit of activity going on there yet. Although it appears to have subsided a little bit from yesterday, there's still quite a lot of activity. big global pulse happens right there. And then a weird pulse around the equator. Here's a view from the poles. There's that big pulse. Pretty much planet encompassing. Moving on. Check quakes.globalincidentmap.com to check out the last 11 hours of earthquakes. 4.8 in Japan, 4.4 in Japan at depth. They stay on alert. Solomon Islands a 52.3. Not too far from the area that we warned about yesterday, as we've been watching low pressure areas just make a 90-degree turn right on the plate boundary. Also a 4.2 and a 4.3 at depth in Afghanistan. Afghanistan should stay on alert for a mid-level 4, as those quakes are at about 200 kilometers deep. We also got a 6.2 at the Solomon Islands at a very deep depth, 357 kilometers. Indonesia a 5.8, and Japan another 5.5. So there would be no surprise if the coronal hole reconnected, and basically this whole area, we've been having a drought for 7+ magnitude earthquakes. Without looking at the pressure maps, that would be my prediction. Let's take a look at the volcano situation. So we've got Shivaluch, volcanic ash not identifiable in satellite imagery. Sakurajima, exploded, 8,000 foot ash plume. Tukono, 6,000 foot ash plume. Reventador, occasional emissions. Sabancaya, sporadic puffs. And a new one on the list, Barren Island in the Indian Ocean. Discrete intermittent volcanic ash plumes to 3,000 feet. Let's take a look at that one. There you go, there's your Barren Island. Coat an island with volcanic ash, it gets barren. Head to theplanetstoday.com, look at the location of your planets in our solar system here. You can see Mercury is approaching a Mercury-Earth opposition there as we chase Venus, and Venus gains on the Earth. Let's advance it 7 days so you see what happens in a week. Also, if you're up before dawn, you'll see a great Venus and a great Jupiter in the eastern sky. Next, for all you Electric Universe people, we keep spending a lot of money trying to find dark matter, and it ain't happening. Article from phys.org. New detector fails to confirm would-be evidence of dark matter. Wah, wah. Sorry, dudes. Those are electromagnetic fields that are controlling galactic motions, not dark matter. Here's a study presenting a surprising explanation for differences in the southern and northern lights. We used to think this was because of magnetotail reconnection, and now it seems that magnetotail reconnection is actually reducing the disparity between the aurora borealis and the aurora australis. Interesting article here, helps to understand the relationship between the solar wind and the Earth. Have yourself a read if you're interested. We will leave links. Next, stellar winds, the source for the material for the universe, are clumpy. Now, those who watch this channel regularly probably are not too surprised by this, as all elements are, present in stellar wind. This article is about a high-mass X-ray binary. Similar to Cygnus X3, otherwise known as Deneb, what they call a neutron star, or we'll call a massive radio source, orbiting a star, sending out ionized plasma, and it turns out that it's lumpy. I don't know why they thought it was homogeneous, knowing the composition of the solar wind. Moving on. Let's look at a couple transients here, see if anything's going on with Sagittarius A star. Not really. Not since its New Year's Eve party, which was the largest transient we've seen for that radio source for quite a while. If you're not familiar, Sagittarius A star is the galactic core of the Milky Way galaxy. Let's also look at Cygnus X3, otherwise known as Deneb, the tail of the swan in the constellation Cygnus. We actually see a downtick in its activity here. We'll be keeping an eye on it. This thing usually goes into a quiet mode before it goes into a high output mode. And actually, there was a pretty big transient here. I would also like to make note that the largest transient we've seen out of X3 was back in 2009. If you're interested in this sort of stuff, we'll leave links to this also. Head to the Neil Gehrels Swift Observatory, Swift/BAT Hard X-ray Transient Monitor. You want to look up some kind of an object that you're familiar with, or maybe that you're not familiar with. There's hundreds to choose from, and if you want to spend all day going through them, please feel free. This is how you find stuff. Go to Find, type in something that you're aware of, like, oh, I don't know, how about the Vela Pulsar? Click on it, and there you go. There's your transients from the Vela Pulsar. And actually, there has recently been some transients. Check it out. Right near the end of 2018, there was a big transient event at the Vela Pulsar. To give you an idea of what that is, it's another crazy radio source. Here's an image from the Chandra telescope. You can see a radio jet coming out this way. And we're looking at this thing kind of from about a 45-degree angle. Super interesting. Check it out, the Vela Pulsar. And now we're going back to 171 angstroms again. We've got some filamentary activity on the northeast. Looks like a small coronal mass ejection there. Zoom in on that filament. Let that play through. Also Sunspot 2733. It is a cycle 24 sunspot, by the way, folks. Not sending out any super powerful flares or anything like that, because the magnetic mixing situation is not that intense. Thanks for watching, everybody. Remember, on your way staring at the sun in 171 angstroms, don't drink. And if you stare at the sun, don't drive. And don't drink and drive. And just don't drive.